Okay, mining plastics out of the ocean and converting it to diesel with pyrolysis. The plastic pollution in the ocean is so vast that it's very difficult to quantify. This is problem one. Microplastics are corrupting the food chain within the ocean. Most governments are unaware of this or have no viable solution as it's in international waters. Problem two, oil will soon become unreliable as a source. Diesel fuel is a vital source of energy which society depends upon. Finland needs a sustainable source of diesel fuel which it directly controls. In the past, diesel fuel from pyrolysis of plastics has struggled to be viable due to the need for volume of feedstock. The idea I'm about to present removes this bottleneck. I'm going to pull together all of these ideas. Here's a heat map of plastics in the ocean as released by NASA. Every year, something like 10 million metric tons of plastic end up in our oceans. It's about 10% of what we manufacture. It's the equivalent of 5 grocery bags filled full of plastic for every foot of coastline around the world. This was in 2015. The idea I'm presenting today, the target is the North Atlantic Gyre. These plastic waste are concentrated into parts of the ocean with ocean currents. We call them gyres. These gyres have increased tenfold each decade since 1945. It is estimated by the time we get to 2025, that annual input will be something like 10 bags full of plastic per foot of coastline. And now that we have COVID-19, we have a new waste stream, the masks. So the Great Pacific Gyre, this is where most of the data exists, it's an island of trash twice the size of Texas, and in the centre of the island it's up to 10 metres in depth below the water. Researchers have claimed this patch covers 1.6 million square kilometres. The plastic concentration is estimated up to 100 kilograms per square kilometre, going down to 10 kilograms per square kilometre at the edges. An estimated 87,000 metric tonnes of plastic in this patch alone, or 1.8 trillion pieces. Most of the mass, like 90% of the mass, is objects larger than 0.5 centimetres, while 94% of the total objects is represented by microplastics, which are generally of the order of 100 microns. Previous attempts to clean this up haven't really been worked out very well. The problem is you can collect the waste simple enough, but due to these massive volumes, they have to be transported back to land to be recycled. And the logistics of going such a long distance tend to make this difficult and impractical. And often the very fine microplastics are overlooked, and that's actually what's causing most of the problem. So the waste needs to be processed into a very small volume out at sea. Problem two, oil. Currently, society is highly dependent on oil as an energy source. Diesel fuel in particular runs our truck, bus and maritime fleets. The economic viability of the oil industry is declining. Sounds strange, but it's true. Most of the oil is sourced from outside Europe and then imported. Soon oil will become the subject of more intense geopolitical competition. Finland needs an ethical and sustainable source of diesel fuel to run critical services. The idea I present today, I would like to see the Finnish government own this ship. Oil and gas discoveries over the last few decades. As you can see, most of it has occurred in the 1960s. In that little red square on the right-hand side sits the study done by Rystad in 2019. And in that study, they had a record low discoveries in 2017, and 81% of existing producing fields are in decline. Of the top modern 10 producing fields, the youngest was discovered in 1976. The viability of the oil and gas industry is also declining. We have a closing window. The oil price in some circumstances is too high for consumers to access. It is also, that same price is too low for producers to survive. When that window closes, the oil industry will struggle. Solution: process plastics at sea with pyrolysis. Take an oil tanker. Right now they're cheap. Take an oil tanker, collect the plastics from the ocean. sort it into substreams, rescue any wildlife, which there will be lots. The plus 2 millimetres will shred to minus 2 millimetres. The minus 2 millimetres will be sucked in as water, put it through a centrifuge, and then do gravity separation. Take the products from that and wash in potable water and put it into pyrolysis, which we'll go through in a sec. Use fractional distillation, and what comes out the other end are usable products of gasoline, diesel, heavy oil and carbon black. Most of it is diesel. So, rubbish goes in one end, a clean ocean comes out the other, and diesel fuel. Pyrolysis of plastics is the heating of something, in this case plastics, without oxygen. Things break down to oil. That oil has similar characteristics to diesel fuel. Approximately 230 millilitres can be produced from 500 grams of plastic waste, depending on the density. And so with the use of fractional distillation, we can turn it into usable products directly. The Pacific Gaia has estimated 87,000 tonnes of plastic. That could be, in ideal circumstances, being converted to an estimated 40 million litres of diesel, or 1.52 pentajoules. Put this in context, finished diesel consumption in 2018 for the whole year was 96 pentajoules. Ah, really? So, take an oil tanker, refit it. Here's a schematic. Rip out the oil tanks. Put in a pyrolysis plant and a sorting plant. Put a big scoop on the front and broadcast a sonar frequency to convince any wildlife to leave the area if they can. Put a solar array along the top and a battery bank under that. Some weather shields on the top for when the weather goes poorly. So, the solar panels run the pyrolysis plant. The diesel that's distilled runs the ship. And if it all lines up, we have a very low operating cost. Benefits? It addresses a major international environmental problem that until now has no solution. It has potentially very low running costs while supplying diesel fuel. The pyrolysis plant can be run on solar, and the diesel fuel can be run from the ship. It develops a sustainable source of fuel without the use of fossil fuels, at a time when access to diesel fuel could become unstable. It would ensure the secure supply of diesel fuel to Finland for decades. And I want you to imagine, if you will, one of these ships going up and down the ocean like a lawnmower, cleaning up plastics. Yes. Kiitos.
Thank you, Simon. I think you really have, again, hit a very big problem with a solution that does sound extremely interesting. Of course, you have mentioned in the presentation how you can take existing ships, existing tankers, and actually refit them so that they would then be not only environmentally friendly, but environmentally positive.
Correct.
And I mean, this is just amazing, isn't it?
And right now they're cheap. No one wants an oil tanker.
This is very true. This is very true. Were there any questions from within here? I mean, I assume one of the next steps would be to get funding for this.
What we need now, none of this is technology that needs developing, it's all off the shelf.
Yeah.
We need a conceptual study.
Which needs funding.
Which needs funding.
Yeah.
But I would like someone like the Finnish government to build a ship like this and run it out of Helsinki. Right, because the diesel fuel that would come from this could then supply vital services. And it's a source that we directly control, and there's none of this crap about using fossil fuels to get it.
That is a very good message.
Yeah.
Did you have a question?
I just wanted to comment that the ocean plastics is a really big problem, as you recognize here as well. And you're not the only one thinking about this. So if you kind of like want to take this forward, there's already a couple of companies in Finland who are working with the ocean plastics. And I think this is adding something new to that. So
Okay,
you may want to connect with them.
I was looking at a large corporation like Suez to take this on, or someone large. A large corporation that needs an AIF. All is forgiven. Right?
There's, for example, a Finnish company called Lamor who are working with the oil
Yep.
collection techniques. So you might, want to look into that direction maybe.
Send them this material.
Sounds really good. Okay, thank you so much for presentation 1 and presentation 2.
Kiitos.
Really good.
Merci, au revoir.